Hello, good day everyone. My name is Cheryl Jackson and I'm here in the coastal laboratory. So right now we have a flume in the coastal area and it is 10 meters long. So a flume is like a big aquarium. It holds a lot of water in it. And at the end of it, we have a wave generator. And this wave generator is either a paddle type or a piston type. And what happens, there are two pieces of paddles. And the one in front basically generates the waves, and the one in the back, it's like a dampener. So this one is the dampener and dampens the waves. So what generally happens, we could set in our computer the kind of wave we need to get run, and then we'll be able to run it. So we have here in our computer software, so we have either the sine, we could run a sine wave, or we could run a synthesis wave, which is a random wave. So what we are going to do, I'm just going to show you a simple sine wave being run. The water height at this level is 0.35 of a meter. So we have to first tell the generator how much water we are going to set to it in order for it to be able to move. Okay, so this is the water here that we're looking at. And let me just walk down to the end of it and show you exactly what we have also at this end. So we have an impermeable beach here. And this impermeable beach is at the slope of 15 degrees. Right? So the water is here and we have, this is like, here it's the still water line. So there you can see where the water stops and hits our impermeable bed, which is just a piece of board. For this instance, we are looking at the wave running up and down the board. And as you can see, we have some grids at the side, so we can see when the water does run up and down. So you can see the grids, and when the water moves up and down, you'll be able to see it. We also have another piece of equipment here. This is called the ADV, and this is the acoustic Doppler velocimeter, and it measures the water velocity. So as the water runs up and down here, we are going to see it, and then that measures the velocities here in the X, Y, and Z direction. We also have some wave gauges here set up. We have 6, 1, 2, 3, 4, 5, 6 gauges set up here. And as we could look inside of it, it is into the water column. And these wave gauges, when we have to set them up, it has to be calibrated. It has to be calibrated so that you will be able to know the wave height. Right? So this is what we are going to do now. I'm going to run a normal sine wave, and you will see the difference between a sine wave and a random wave. So we're going to use our sine wave. Let's say we have an amplitude of 0.3 and a frequency of 0.5. Actually, let's go down to the amplitude of 0.2 and a frequency of 0.5. And I'm just going to start it. I put it to run for 2 minutes and we'll see how it runs. So I press start. And as you can see, the wave generator is now moving. So it measures the amplitude and the frequency. And you can see that a wave is being generated. And as we go down the line, or go down the length of the flume, we can see the wave being generated right at the top here. And we could also see the wave run up, and we can see the water is being covered. The ADV is being covered by the water, so it's going to be collecting data. So as we quickly walk down here, we could also see what is called a standing wave, which means that the two waves are eventually going to meet. So you can see it right here. One wave is going this direction, and the wave is going this direction, and it's meeting right in the center here. You can see a standing wave is being formed. And also when we look in the lee, or in the back of the wave generator, you see how still the water is in the back, which means that the back piston, the back paddle, it's doing its job, and it's stopping wave energy from going in the back. What happens if this was not there, and we had waves going in the back row. Just take a longer while for the water to settle down, and we have to have the water still before we run the second experiment. So as we can see here, this experiment is being run. So what I'm now going to do also, this here is the ADV software. I'm just going to put it to start data collection, and we see data is being collected. However, I'm just going to change my velocity range to 0.1. Let me stop collecting the data here, and let me change the velocity range to 0.1 so you can see the velocities better. So now we can see the velocity a little better. So you can see a nicer curve is being drawn. Right. So what I'm going to do here now, I'm going to run a random wave, which is called a synthesis wave. A random wave means that there are many different waves coming together. So in this case, we will use a John swap wave. You all could probably go and Google that. A John swap wave is just different mathematical expressions to create a wave. So this won't be one single wave. Like how before we had the sine wave and it was one amplitude and one frequency. This time you will have a different amplitude and different frequencies coming together in one wave. So now the water has kind of calmed down a little bit, so I could put the other wave to run and show you all how it will look, so you can see the difference. So as you can see, this is the wave generator, and you can see that there is a different kind of wave that is being formed. So right now these are small waves, and the waves are usually between, let's say, 1 centimeter and 0.1 of a meter. So you can see it's getting bigger and generating a bigger wave. And this time it will go all the way up to the top. I could show you another wave that will be a little bit, that has more energy in it. So let me stop this. Let me find another wave that has more energy. Okay, so we can see here, this wave definitely has much more energy, and you can see the waves rolling along, and then breaking higher up. So we can see it. So you can see the waves are breaking here, and it's going to be breaking here also. This is basically what is done. Okay, thank you so very much. Hopefully, we'll be able to see each other soon. Bye.